Hi there, question 16. In the Clemmensen reaction, ketones are converted into alkanes as shown. Identify the alkane produced if the following ketone was used in the reaction. And this is just pattern matching. Which of these looks the same as this? And the answer is this one. The only one you might get confused by is this one, but if you look carefully you'll see two carbons on this side where there's only one carbon on that side, so it's this one. It's a sort of a little spot the difference puzzle for you, and the answer is B. Which line in the table correctly describes the trends going on from hexonic acid to butonic acid? So, formula mass increasing, hex is actually going to be larger than but, and if you have trouble remembering these, this is methanoic acid with 1 carbon, ethanoic acid with 2, propanoic acid with 3, butanoic acid with 4, and so on. And here's pent, hex, hept, oct. Just getting one more carbon as you go down. So hexanoic acid is going to be larger than butanoic acid, so that one will be wrong. You are left with either B or C. Now, the solubility in water. So acids, the acidy bit, the C, this bit, that's hydrophilic. It wants to dissolve in water. But the carbon chain bit, that's sort of like fat or oil or something like that, this carbon chain bit, that's hydrophobic and that doesn't want to dissolve in water. So this one wants to dissolve less than this one because it's got a longer chain. So which of the table correctly describes the trend going from hex to but? So the chain's getting shorter, it wants to dissolve more. So it will be B, 17B. Right, 18. 4 cells were made by joining silver to different metals. The cells produced the following voltages. Right, so silver was joined to a different metal, and the metals that were used were either copper, zinc, iron or magnesium. And hopefully you kind of know how reactive each of those are, but just in case you don't, we can have a look here and we can see that silver is the least reactive, then copper, then iron, then zinc, then magnesium, and so on. So which voltage was produced in the cell containing silver and copper? Well, copper is the least different from silver. So we have silver here, and copper is going to be the smallest difference between them. So that's going to produce the smallest voltage. And the smallest voltage here is that one. So the answer is going to be 0.5 volts. And just so as a little bit of background, the reactive metal, all metals are trying to get rid of their spare electron that they don't really want, so as they can have nice stable outer arrangements of electrons. But the more reactive metals, they are pushing that electron away stronger than the less reactive metals. So electricity always flows from the more reactive metal to the less reactive metal. Or the electrons flow that way. Question 19. Information about the reactions of 3 different metals are given in the table. Which of the following shows the metals in their order of increasing reactivity? So the one that reacts the most is the most reactive. Most. The one that reacts the least is the least. And the one that reacts some of the time is middle. Bit easy, that one. So in order of increasing reactivity, Y would be the least, then X, then Z. So be that one. So least, middle, most. Yes. So C. Question 20. A copolymer is formed when 2 different monomers polymerize. Part of the structure of a copolymer is showing 3 monomer units is given below. One of the monomers used is propene. So propene, prop has 3 carbons. So propene will look like that. So yeah, I haven't drawn that very well. I'm going to do it again. Oh. So propene has 3 carbons. And I've shaped it this way because things always join together just across that double bond. When that double bond breaks, it can link up on either side. So let's just draw in 2 more hydrogens there. Draw it properly. And another hydrogen. And make sure there's 4 bonds around every carbon. Yeah. So that's propene. And the other monomer is going to be, is it going to be a bute or a pent? A bute will have 4 carbons and a pent will have 5. So if we imagine one with 4 carbons, maybe something like that. Will that join up in such a way that it could look like this? Yes, I think it could. I think a butene would be able to join up with a propene to form this collection here, because we'll have one like that and we'll have another one sort of like that, and that sort of looks similar to this. So I'm going to say butene C. Thanks for watching. Bye.